Okay, so lesson 41, we learned what a system of equation is. We're going to call those SOEs. And today we're going to show you how to solve them. Now, basically it's this. You're going to have different scenarios pop up for you, but for the graphing method, it's basically this. Take both of the equations that are in your SOE and graph them on the same coordinate plane. If the two lines cross each other that you graphed, where they touch, that's your solution. You'd get your ordered pair, your coordinates of that point, and that is your solution. It's that simple. Now, what happens if you come into this very special situation where you go to graph the first equation and then you graph the second equation and suddenly you realize they're going to be exactly on top of each other? Well, we call that infinite solutions because any point on those lines would solve both of the equations because basically they're identical. And then the very last one is there is a no solution scenario, and that's where basically the lines would not touch at all. They have the same slope, and so if they don't touch, it's no solution. So that being said, let's get in to actually show you how to do this. Graph the equations to solve the SOE. So right here, you'll see that we have two equations. Right here, y equals 1/2 x plus 3, and down here we have y equals 3/2 x plus 1. So let me go get a green pen and we will go and graph y equals 1/2 x plus 3. That way you'll have an understanding, color coding how it is. The y-intercept is 3, so we'll put a dot at 3. And then we go up 1 and over 2. And just a moment. There we go. We've got a line there. Let's go and use a blue dot to graph this one. Let's see. The y-intercept is +1, so we'll put a dot there. The slope is 3 over 2, so we'll go up 3 and over 2, and you'll see we hit this dot right here. And that's where our lines are going to intersect, and they're only going to hit in one spot. So as a result, we know that the solution is going to be 2, 4. This dot right here is 2, 4. That's the solution, 2, 4. And I'd like to take just a moment here to show you, just for this one, why it's true. Let's take the x value and the y value and plug them into both equations. Well, 2 times 1/2 is 1, and 1 plus 3 is 4. And that's what it was supposed to be. So now let's take this one into here. 3/2 times 2 is 3, and 3 plus 1 is, we said the y was going to be 4. So it made both of these equations true. Let's go on down and take a look at example number 2. Let's see, we'll put the top one in green and the bottom one in blue. So our y-intercept is -2. And we've got a +1 for the slope. So up 1, over, up and over. And you see the pattern. And you know how it is. You can kind of extend the line as far as you really think you need to. That makes that look a little better there. And let's go through and graph the other one. The y-intercept for the blue equation here is 2. And we're going to go up 1 and over, up and over. And as you can see, what's going to happen is we're going to get basically two lines that are never going to intersect. So there is no solution. Now, to save yourself some time here, if you take a look at the equations, you might be able to speed up the process. You have the exact same slope. I mean, the exact same slope. But you have different y-intercepts. So it means same slope, but they're crossing the y-axis at different points. They're never going to touch. So you might want to pay attention to that. That can save you some time. Anytime they have the same slope but different y-intercepts, it's not going to have a solution. Now, this is going to be an example of infinite solutions, but it's also an example of, hey, you should know how to graph anything that's thrown your way. We know how to graph this first equation, so let's go do it. Let's see. +2 is our y-intercept. Slope of 5, we can't go up 5. So we're going to go down 5 and back 1. There you go. That's pretty good. I need to swing this point over just a little bit more. There we go. Now, how do we graph a standard form linear equation? Hey, you've got to remember how to do this old stuff. Add 25x to both sides. So this goes away. 5y is left over. Our 25x comes down first, and the 10 falls down behind it. What do we do now? We divide by 5. And we're left with y equals 5x plus 2. Now, do you see that this matches this? You didn't know it at the beginning, but basically we're going to have a y-intercept of 2. We can't go up 5 and over 1, so we're going to have to go down 5 and back 1. It's the exact same 2 points. So any point on this line would solve both of these equations. So you would say, hey, infinite solutions. And does anybody remember the sign for no solutions? Yeah, 0 with a line through it. So there you go. That's the graphing method. Graph both of the lines, and if they cross once, that point where they touch is your solution. It'll make both of them true. If the two lines never touch, it's no solution. If it's the exact same line, it's infinite solutions because any point on this line would make both of these equations true.